Hi, hello, welcome back to my channel Knowledge Center. In this second video where we are solving about the KPTCL question paper which has been asked on the junior engineering post, and it is asked in the year 2017. Okay, you can go through the previous video wherein I have solved 5 questions on this paper. Now I am going to continue with the further questions. To have a previous video, you just click on the link which is provided in the description. Now let's begin with the first question from this video. Among the following, which one have zero average value in a plane electromagnetic wave? So in the electromagnetic wave, which field or which option will have a zero average value? That's the question. So it's a simple one. In an electromagnetic wave, you can look into the picture here. We can have a magnetic field as well as the electric field. Both electric field, see this red color is an electric field indication and this is a magnetic field, blue one. So both fields are going to have a sinusoidal wave, and in the sinusoidal waveform, if you consider the average value of the sinusoidal waveform, it will have positive cycle and as well as the negative half cycle. So the average value of this sinusoidal waveform will be 0. So based on this concept, we can say that the average value of sinusoidal wave is 0 because the magnetic field will have a sinusoidal in nature. So the option A will be the answer for this question. It has been asked in the question paper. Yes. So a basic question with a simple concept. Now let's move on for the second question. What is the electric field at origin if while moving on the axis from x equal to -1 centimeter to x equal to plus 1 centimeter, the electric potential decreases uniformly from 120 volt to 80 volt. So here we know that there is a change in voltage and even there is a change in distance. There is a movement of an electric field. So we have an equation that the electric field can be given as change in voltage, that is delta V, by change in distance, that is delta x. So the minimum electric field would be here. What is the change in volt? Minimum change in voltage is here 80 minus 120, that is 40 volt, and the change in distance will be -1 centimeter to plus 1 centimeter. So that is 2 centimeter. 1 minus of -1 is 2. So 40 by 2 will give the 20 volt per centimeter, and this would be the minimum value of the question, electric field, of the electric field. So we can say that the electric field may be equal to 20 volt per centimeter, or it may be greater than that, because 20 volt per centimeter is the minimum value we are getting. So option A will be the answer for this given question. Let's see the third question here. How will the dynamic plate resistance get impacted if a triode is operated in the linear region of its characteristics and the plate voltage is slightly increased? Okay, so in a linear region, so first of all you need to understand that the dynamic resistance is given by R is equal to V by I, that is the change in voltage by change in current, and it is mentioned that this triode is operating in a linear region. So in linear region, what happens? Linear region in the sense, with the variation in the voltage, there should be variation in the current also. So change in the value of voltage will be equal to the change in the value of current. So delta V, if the voltage increases, the same part of current will also increase. If in that case, we can say that the resistance will almost remains the same. There will be no much variation because it is in linear region. If voltage increases, current also increases, so the ratio of that will be same. Okay, so option A would be the answer for this question. I hope you are understanding the concepts. See, if you are happy with these videos, just put your feedback in the comment box, and also don't forget to share, like and subscribe to my channel there. Let's begin with the next question here. The current passes through a resistor. Let K1 and K2 represent the average kinetic energy of the conduction electrons and the metal ions respectively. So now the question is, which one is greater, whether the K1 or the K2 or both are equal? So by considering the law of conservation of momentum, so momentum of the electrons, based on that we can say that the electrons possesses very high drift velocity. It's greater than the velocity of ions. Okay, so velocity of electrons will be greater than the velocity of ions. Keep that point in our mind. So based on that, we can say K1, that is the velocity of the electrons, is greater than K2. So option C would be the answer for this question. Now let's move with the next question. What will happen to a compass needle if it is placed in the gap of a parallel plate capacitor and the capacitor is connected to a battery through a resistance? Okay, so we have a relation here. The compass needle means when we have a compass in between the two capacitor plates, that compass is a magnetic field, and there will be magnetic field in between the capacitive plates. So the magnetic field is produced when there is a changing electric field inside it. So as the capacitor is connected across the battery, the charge on its plates at a certain time is given by Q is equal to CV into 1 to the power minus to the power of e to the power of t by RC. So here R is nothing but the resistance which we are connected in series to the capacitor, and C is the capacitance value. So based on this R and C, the charging parameter is going to depend upon this R and C, that is that tau. We denote it as tau. Okay, so initially the capacitor, the magnetic compass needle will be deflecting. So deflects and gradually it comes to the original position in a time which is large compared to the time constant. It is compared to the time constant, it is going to be large, but means initially it will be deflecting. Later on gradually it comes to a rest condition or original position. So means initially it is charging, the capacitor is charging, so there will be a deflection. So that option would be the answer for this question. Let's go with the simple question. Another simple question which has been asked in the question paper. It's pure electrical. 3 single phase transformers of ratio 1:10 are connected in delta star to supply a 3-phase star connected load. The primary side is connected to 3-phase 400 volt supply. The line voltage on the load side is dash. It means you need to find the line voltage on the load side. Load side is nothing but the secondary side where actually the load is connected. Okay, so primary side there is a 400 volt and they have given that 3 single phase transformers ratio of 1:10. So according to this we can say secondary voltage is 10 times of the primary voltage, that is 400 volt is the primary, so secondary voltage will be 4000 volt. And we have a relation for delta to star. It is a delta star connection. So delta, if you have a delta, in delta if it is 400 volt means VL and V phase will be same in delta. Whereas when you come across the secondary side, in secondary side it is connected in star. So in star the relation changes like this. VL equal to root 3 V phase. So they asked you the question that what would be the line voltage on the secondary side, that is load side. So VL will be equal to root 3 V phase. V phase is, what is the value of V phase now? It is 4000 because it is 1:10 ratio. So 4000 into root 3, option C will be the answer. Among the following, by which of them the electric conduction in a semiconductor takes place? See, in a semiconductor there will be a motion of an electrons, and because of the holes we get this movement of electron. So both electrons and holes are responsible to have a conduction in semiconductor. So option A would be the answer. Now let's move for the 8th question. If there is a space charge in a diode valve, dash happens. So see what actually space charge in this sense. If we have a diode, there will be a cathode and anode. So this space charge consists of a negatively charged region is called space charged. The negatively charged region in a diode is named as a space region. Okay, and in that space region what happens, that will repulse the negative electrons, or it will, we can say that it repels the negative charges. From the cathode, electrons will be trying to move towards anode. Due to the space region, those electrons will be repelled back to the cathode. So it's nothing but the movement of electron has been reduced. If movement of electron is reduced, there is nothing but the current is decreased. So option A, that is the plate current decreases, will be the answer for this question. I hope you understood the logic behind this. Okay, let's begin with the next question. A fully charged parallel plate capacitor having charge Q is filled with a dielectric slab. The magnitude of the induced charge on each surface of the dielectric is Q dash. Then dash happens. Okay, means there is a fully charged parallel plate capacitor. So when we have a charged capacitor, both the plates will have electrons when charge Q. Okay, and it is filled with a dielectric slab. So dielectric slab is nothing but that is a non-conducting material. So if you have a non-conducting material, then the conduction or the moment of charge will be less. So the magnitude of the induced charge on the surface of the dielectric is Q dash. So definitely we can say that the two plates charged with the charge of Q, and in between those two plates we have a slab which is of dielectric material. Assume that it's a wood. Okay, so definitely the flow of charges in that hood will be very low. So we can say that the Q dash, that is the charge what we have on the surface of the dielectric slab, has to be less than the charge what we have on the plate. So the Q dash must be smaller than Q. Okay, now let's come to the last question of this video, and to get more questions you subscribe to my channel, so that whenever I upload the new video you will get the notifications in the YouTube, and you can go through all the videos without missing even single concept. So this is about the aptitude kind of question. Rupees 300 is distributed among A, B, C such that A gets 2/3 of what B and C together get, and C gets 1/2 of what A and B together get. Find C's share. So they are given some information. You need to find how much of amount is shared among C. Okay, so first let us write what actually they have given clearly. A plus B plus C combinedly they get 3000 rupees. Okay, it is distributed among A, B, C. Okay, that let me take it as an equation 1, and it is given that A gets 2/3 of what B and C together get. So I can write it like this: A equal to 2/3 times of B plus C. So whatever the amount got by B plus C, it will be A will be having 2/3 of it. So let me take this as third equation, and they given another condition that C gets 1/2 times of A plus B. Okay, so these are the given data in the question. Using this you need to find what actually the C is going to get. So by looking into this, we can say C is equal to 1/2 times of A plus B. So if you know A plus B, you can get C. So how to know A plus B? We have equation 1. From equation 1 we can write A plus B is equal to 3000 minus C. So this you can substitute in equation 3, where we have C equal to 1/2. In place of A plus B, you put it as 3000 minus C. So we got C as a common parameter in both LHS and RHS side, and you need to find only the value of C, and that is unknown. So simplify it. What do you get here? C is equal to 1500 minus C by 2, or 0.5 C. Okay, then take that 0.5 C to LHS side. So it is minus 0.5. Now it is going to become plus 0.5. So 1 C plus 0.5 C will be 1.5 C equal to 1500. Therefore C is equal to 1500 by 1.5. That's nothing but the share amount of C is rupees 1000. C is going to get 1000 rupees. So option A will be the answer for this question. I hope you understood all the concepts here, and if I feel that you are enjoying these videos and also understanding and learning the things. If it is helpful for you, just press the like button, share among your friends. Don't forget to subscribe to my channel here. Thank you.